Sé que muchos de ustedes vienen de afuera y como podrán haber visto desde el avión o de los autos, Santiago es una capital que está rodeada por las montañas. Mi nombre es Raimundo Sánchez, yo soy profesor de la Universidad Adolfo Ibáñez, hago clases de analítica avanzada y hoy en día estoy enfocando mi investigación en temas de analítica deportiva. ¿Por qué cuando yo hablo de deporte también hablo de montaña? Bueno, porque como Santiago es una ciudad que está rodeada de cerros, una de las grandes prácticas deportivas dentro de esta ciudad, específica de Santiago, tiene que ver con el senderismo, con el mountain bike, con el trekking y con una gran cantidad de deportes relacionados con los cerros. Así que hoy día les voy a mostrar más o menos algunas de las preguntas de investigación que estaba tratando de resolver. Arriba alcanzó a mencionar el tema de datos espaciales. A mí el tema de los datos espaciales me fascina. Me fascinan los mapas, me encanta mirar los mapitas. Yo trabajé mucho tiempo en el Centro de Inteligencia Territorial en la Universidad de Barcelona. Ahí desarrollé mi pasión por los mapas y en los últimos 5 años he aprendido a construir diferentes tipos de visualizaciones geográficas utilizando exclusivamente el lenguaje de R. Acá en este mapa podemos ver que está la ciudad de Santiago. Esto es lo que nosotros llamamos la mancha urbana de Santiago. Y como pueden notar, estamos rodeados por montañas en todas direcciones. Hacia el oriente podemos ver que está toda la cordillera de los Andes. Hacia el poniente podemos ver que está la cordillera de la costa. Y también Santiago tiene un montón de cordones montañosos entre medio, como por ejemplo el cordón del Manquehue. Tenemos acá el Cerro Chena. Y ahí se puede ver el Parque Metropolitano de Santiago, que está cerca de la ubicación donde nosotros ahora estamos actualmente, y que es un parque que tiene el doble del área del Central Park, solamente con la diferencia de que es un parque totalmente cubierto por cerro. Entonces Santiago, en los últimos 5 años, ha sido el escenario de una de las tendencias deportivas que se lo llaman las carreras de montaña. Yo personalmente soy corredor de montañas. De hecho, hoy día mismo voy a viajar al sur a una carrera en el sur del Puerto Madero. Y hace como 4 años empecé a formar un colectivo de corredores de montaña que se llama Run to the Hills. A mí me gusta mucho correr por los cerros y lo que más me llama la atención de Santiago es que yo tengo la posibilidad de salir corriendo desde mi casa y subir el cerro y volver todo a pie. No tengo la necesidad de tomar un auto para poder ir y practicar senderismo en esta ciudad. Y hay muchas zonas de esta ciudad que permiten la práctica del senderismo sin tener que tomar medios de transporte. A veces uno puede ir en bicicleta o también puede ir en transporte público, pero como les decía recién, como esta ciudad está rodeada de montañas, hay una gran parte de la ciudad que puede acceder a los cerros de manera más o menos accesible. Y esa fue una de mis principales preguntas de investigación. Lo primero que yo hice para tratar de entender bien la distancia o al revés, la cercanía hacia los cerros, fue tratar de mapear todas las trayectorias de las salidas a correr. Ahí está mi casa, ese es el epicentro de todas mis carreras. Entonces, como pueden ver, yo con mis amigos salimos a correr desde el barrio donde vivimos y vamos al Cerro Manquehue y bajamos, o vamos al Santiago de Chile y bajamos, vamos hacia el centro y bajamos. Y eso es porque nosotros tenemos la fortuna de vivir en este sector donde el cerro más cercano está aproximadamente a 2 kilómetros de la puerta de mi casa. Entonces esa fue la pregunta que me salió. Dije, ¿cuál es la distancia que hay al cerro más cercano desde toda la ciudad de Santiago? Están todas las manzanas de esta ciudad con este privilegio, todos tienen la posibilidad de llegar al cerro de manera tan fácil y accesible como yo. Esa fue la pregunta que traté de responder y ahora les voy a mostrar más o menos cuál fue la estrategia que utilicé utilizando R y la ciencia de datos para poder responder esa pregunta. Entonces lo primero de este análisis comienza, ¿cierto?, con un mapa. R tiene un montón de paquetes especializados para poder estudiar mapas. En este caso yo utilicé una herramienta que se llama Map, que probablemente las personas que han trabajado con datos geográficos, con datos espaciales, han ocupado esa herramienta. Y Mine es una herramienta súper versátil que te permite acceder a un montón de repositorios de mapas públicos. Entre ellos, obviamente, uno puede acceder a Google Maps. Google Maps te pide una API, y si uno consulta muchas APIs, te empieza a cobrar. Así que Map también te permite acceder al repositorio de Statement Maps. Statement Maps es un map stack, en fondo un repositorio de datos que es gratuito, Y ustedes pueden acceder a todo el repositorio de Statement Maps simplemente con una query muy simple en R, y tiene una de las grandes ventajas que te permite acceder a mapas con varios niveles de zoom, de resolución. En este caso yo ocupé Statement Maps y lo que decidí fue poner como la capa de base del mapa que vamos a construir, un mapa del terreno, un mapa del territorio. Ojo que esto no es una foto satelital, es un mapa, es una renderización del terreno de Santiago. Por lo tanto, en cada uno de los píxeles, lo que uno ve son solamente colores. Este mapa, este raster que uno descarga desde Digimap, no contiene más información respecto de la topografía. Entonces yo dije, ¿sabes qué? A mí me gustaría complementar esta lista de mapas con la lista topográfica. Porque ya que a mí me interesa medir la distancia con los cerros, me interesa saber también cuáles son las elevaciones de estos distintos cerros, y por lo tanto lo que me interesa es poder cruzar la visualización que estamos viendo acá con las líneas topográficas. Algo más o menos así. De esta forma nosotros podemos ver, gracias a otro paquete que se llama LatinR, podemos ver que cada una de estas líneas rojas representa un nivel de altura sobre el nivel del mar. Y por lo tanto podemos ver la topografía de toda nuestra ciudad. Y ahí se puede ver claramente dónde están las cimas de las montañas. LatinR es una aplicación que básicamente consume un recurso generado por Marcel. Marcel lo que hicieron fue un modelo de elevación digital, que es muy similar al modelo de elevación digital que tiene Google, pero tiene la gran ventaja de que el modelo de elevación digital de Marcel es open source, abierto y totalmente gratuito. ¿Ya? ¿Qué es un modelo de elevación digital? Básicamente es un modelo de datos para los cuales para cada coordenada X, Y, latitud, longitud del planeta, este modelo de elevación digital almacena un valor de altura. Y lo que hace Marcel a través de la plataforma LatinR, uno accede a través de una API y puede conseguir todas las elevaciones también en otro modelo raster, que yo en este caso solamente extraje los contornos de los cerros y las líneas de desniveles que están divididas por cada 100 metros de altura. Esas son configuraciones relativamente sencillas de hacer en R, y con eso ya podemos identificar más o menos dónde están las cimas de las montañas. Ahora, para poder seguir construyendo este mapa, a mí lo que me interesaba era identificar dónde están las cimas, dónde están las cumbres. Y ahí hay un enfoque que es data driven, porque uno podría tomar efectivamente estas curvas de nivel, buscar dónde están los máximos locales y tomar cada uno de esos máximos locales como una cumbre o como la cima de una montaña. Este enfoque, a pesar de ser relativamente sencillo de implementar, empezaba a generar un montón de montañas que no eran tal. Hoy en día existe una definición por la Asociación de Andes-Camus, la cual define una montaña aquella cima que tiene más de 100 metros de longitud. Y el enfoque de los máximos locales generaba un montón de cimas que no tenían esa característica. Entonces el enfoque que tomé para identificar cuáles eran los puntos fue un enfoque alternativo, no fue tan data driven, pero sí tomé información que fuese pública y esté en internet. Finalmente lo que hice fue tomar cimas que están reconocidas por la comunidad y que hoy en día se encuentran publicadas en algún sitio web, como por ejemplo Wikipedia. Entonces en Wikipedia uno accede, por ejemplo, en Wikipedia en español aparecen del orden de 60 cumbres dentro de Santiago. Así que tomamos Wikipedia, aplicando las herramientas de RBest y también de Peer para poder ordenar los datos, porque hay un montón de cumbres duplicadas. Pudimos generar todos los puntitos verdes que se ven acá, que son las cimas de los cerros de Santiago. Eso también lo aplicamos a otro par de sitios que contienen un montón de coordenadas y ya tenemos más o menos las cimas. Después complementamos esto con información de Strava. Strava es una aplicación donde uno puede registrar las trayectorias cuando uno sale a hacer ejercicio, y eso uno lo pone sobre el mapa para poder identificar cuáles son los accesos al cerro, porque yo no saco nada sabiendo solamente la coordenada, me interesa saber cuáles son los potenciales trekkings, los potenciales senderos que yo puedo utilizar, y eso lo implementé súper fácil con una app, con una librería que se llama Strava, una librería que no está en CRAN. Entonces, para poder utilizarla, uno también tiene que aplicar la herramienta de DevTools pero con eso uno puede mapear de manera súper fácil, uno consulta la API de Strava y puede sacar todas las trayectorias que los atletas hacen dentro de las distintas ciudades. También lo complementé con otro tipo de senderos y tengo más o menos todos los senderos de trekking dentro de la ciudad, y con esto ya puedo empezar a calcular las distancias, que es lo que podemos ver acá en este gráfico de color. Acá podemos ver la distancia desde cada manzana de la ciudad a cada uno de sus cerros más cercanos. Y con esto, bueno, lo calculé utilizando una librería que se llama Regeos, y básicamente lo que podemos ver es que hoy en día en Santiago el 25% de la población tiene un cerro a menos de 3 kilómetros de distancia de su casa. 25% de la población, estamos hablando de 1,7 millones de personas. También podemos ver que un 66% de la población de Santiago, estamos hablando de casi 5 millones de personas, tiene un cerro a menos de 6 kilómetros de distancia. Por ahí se me movió un poco la línea, no importa. Y lo que más me llama la atención es que el 100% de la población de Santiago tiene un cerro a menos de 10 kilómetros de distancia. Y con esto yo me gusta reafirmar que Santiago efectivamente es una capital y debería ser una de las principales ciudades donde se desarrollan estos deportes al aire libre, entre los cuales estoy hablando del senderismo, trekking o también el mountain bike. Bueno, finalmente apliqué todas las virtudes que tiene ggplot para terminar el mapa con la leyenda y que estuvo bonito. Y este es el mapa que finalmente publiqué hace un par de días en las redes sociales y que también lo pueden ver en ese link de GitHub en una mediana resolución. Bueno, para finalizar esta exposición, los quiero invitar a hacer zoom a donde estamos parados hoy en día. Este es el mapa de todo Santiago, pero nosotros hoy en día estamos acá en el centro de extensión de la Universidad Católica. Y el centro de extensión de la Universidad Católica está a menos de 1 kilómetro del cerro más cercano. De hecho, cuando ustedes salgan acá, si es que el clima alcanza a mejorar, ustedes van a poder ver al Cerro Santa Lucía, que está a un par de metros, pero la cima está a menos de 1 kilómetro, son solamente 15 minutos para caminar hasta la cima. Y si tienen un poco más de tiempo en los próximos días, los invito también a visitar el Cerro San Cristóbal, que es el cerro más alto del Parque Metropolitano de Santiago, que es uno de los principales parques y de los principales atractivos turísticos de esta ciudad de Santiago, capital de montaña. Muchas gracias por su atención.
Hola Raimundo, muy linda la presentación. ¿Podés volver a mencionar la API alternativa a la de Google?
Hay dos, porque hay una API alternativa, o sea, el Wikimap tiene dos alternativas de mapas, ¿cierto? Que cuando tú consultas la API de Google Maps, te cobran después de un cierto número de consultas y es carísimo. Todos los que lo han usado ya se han dado cuenta que llega el billing a fin de mes y no fue una buena idea. Entonces, en el caso de Wikimap, tiene el repositorio de mapas que se llama Stamen Maps y Stamen, y esos mapas son absolutamente gratis. Y por otro lado, también la API de LatinR, que utiliza los datos de Mapsen, también es un sustituto de Google, porque Google también tiene la Elevation API, que sigue siendo igual de cara que la de Google Maps, y en este caso la LatinR, a través de los datos de Mapsen, tú puedes acceder absolutamente gratis a todos estos datos con un nivel de resolución más o menos de 10 metros. Lo que hace Mapsen es que ellos tomaron un set de datos generado por el Shuttle Radar Topography Mission, que fue un proyecto de la NASA del año 2003-2004, y en ese proyecto ellos, a través de un montón de tecnología satelital, mapearon la elevación de cada punto de la Tierra y lo han ido actualizando un par de veces a lo largo de los años. La gracia de Mapsen es que toma esa fuente de datos y la enriquece con otro set de datos que, como te decía recién, es absolutamente libre. Está disponible en Amazon Web Services. Y yo con mis colegas hemos estado estudiando la precisión de sus modelos y es suficientemente buena para prescindir de la API de Google. Bueno, gracias.
Bueno, y ahora, muchas gracias Raimundo. Toca la primera Keynote de LatinR 2019 y tenemos el honor de recibirla a Mine Çetinkaya-Rundel, que es profesora en la Universidad de Edinburgh, en UK, y también trabaja en los estudios, es una referente de educación, así que nos va a estar, si no estuvieron en su tutorial ayer, ahora nos está contando bastante de lo que hace. Así que le damos la bienvenida a Mine.
Good morning, and thank you very much for having me here. Today, I wanted to talk about a topic that's near and dear to my heart. I talk a lot about teaching R and kind of the nitty-gritty of doing so, but I think there is another aspect of teaching anything, really, where we step back and think about, are the methods that we're teaching with really accessible to everyone, that we want to have in our classrooms? Are we inviting everyone into the classroom, and are we kind of elevating them to the same level? So, let's start with this. So you want to teach R. What are some of the things you should be doing to begin with? This is something I've learned from my colleague Greg Wilson. The first thing you should do is actually write learner personas. If you don't know what they are, I highly recommend reading about them. They are incredibly helpful to help you gauge who you think this class is for, whatever that class environment is, either it's a semester-long course or a 2-hour workshop. So start with that. Then, as any good educator, I should tell you that you should write out your learning goals. If you are an educator, you probably recognize that triangle. That is the Bloom's taxonomy triangle. You should probably come up with your list of topics. There should be a syllabus with some rules of how the course is going to run. Figure out what your resources are, textbooks, so on and so forth. The computing infrastructure is something you definitely want to be thinking about before you set out to getting people into your class. How are they going to access the computational resources? How is the entire class going to run? But is this it? This could be it, but I think there's one other thing. So I'll try something, but I haven't tried one of these before, so we'll see how this goes. So I'd like you to think back to when you were first learning R, or the first programming language you learned, if that's not R for you. What about the instruction made it more challenging for you? So I will try. He is very cute. He actually doesn't look like that anymore, but that picture. Okay, so I would like you to think about, once again, back to a time when you were first learning R, or the first programming language you learned, and what about the instruction made it more challenging for you? And you should be able to actually send your responses here. The hi was for me last night trying to figure out how this works. So if you can't think of anything that made it challenging for you, go ahead and send me your answers. I'll give you a minute or so to think about that. You should be able to go to slido.com and then send 305.
Connection lost. I think you have to change the access point.
If not, we'll roll with it. Keep those thoughts near and dear to your heart. Or tweet them out, better yet. Why keep them in? Okay, well, I want to try this, but I think it's, I'm having difficulty with the internet connection, so I'll leave it for now. But if you have thought of something, feel free to tweet it out or shoot an email to me. I'd love to collect these things, and I'll tell you that the thing that was like a moment of, oh my God, I will never be able to do this, for me is somewhere in my slides, and I'll tell you when we get to that point. But I think that each one of us probably have, whatever you were learning, whether that was a natural language or a computing language, something about the instruction that you wished were different. There's potentially a very good reason why things were the way they were, but I think there's more we can do in terms of thinking about how are we exposing our students to R in this context, and what better things can we do in terms of feeling each and every one of them feel welcome in the classroom. So the first thing is getting students interested, right? That's getting somebody into your classroom is the first step. I think actually we're kind of at a good time for it. Teaching R and data science in this day and age, you can announce a class at a university or a workshop. Things are probably going to fill up because people are interested in this topic. And that's a good thing. That is an incredibly good thing. And that is probably not what I would be saying if I was giving this talk maybe even 5 years ago. But the thing is, we also want to be cognizant of who's coming into the classroom. Is it the same groups of people who happen to know about the importance of R and data science who are coming into the classroom? And are we doing our best to try to reach out beyond these groups to try to get other students interested in it as well? So if you are teaching at a university especially, but even if not, even if in a kind of outside of the university setting running workshops, I encourage you to think about how you advertise your class. I mentioned the universities because within a university setting, we rarely advertise our classes. In fact, I think within academia, this idea of marketing is kind of not, well liked. But I think we need to be doing this because otherwise, the people who are getting the message that this important course is running might just be the same subset of students, and you may not be reaching out to other groups. So things that I've found to be kind of successful ways of doing that is reaching out to people who do undergraduate advising for different subsets of the population that maybe work in something like the diversity office or whatnot, and try to get a flyer of your course to them and see if there may be 1 or 2 students signing up from there. And then at the very end of the spectrum is we want to prepare our students for the next phase. I think that if you are teaching R for data science in this day and age, one of the really good things you can do is you're teaching students for a semester, get them to a point where maybe they have a public GitHub account with one project they're proud of exposing them. That's a really good place to get students to. So I think we often agree on what a good ending point for these students would be, but then comes the middle. We've got these students into our classroom, but we want to keep our curriculum challenging enough so it feels to them like it's worth their while. But at the same time, we want to make sure that this curriculum is supportive enough so that the number of students who fall through the cracks are minimized. Inevitably, this is going to happen, but I think there are things you can do to try to minimize that. So I'll try to go through 10 points. I like doing these like 10 points type of talks. I'll try to go through 10 points for what are the certain things that you can do. The first thing is get to know your students. This seems like a no-brainer, but when I say get to know your students, I mean go beyond the roster that is automatically generated for you, but at the same time acknowledging that it may be, depending on how many students you're teaching at once, it might be really difficult for you to actually get to chat with them one-on-one, every single one of them, and actually have a meaningful conversation. Recently there was a tweet from Andrew Heiss, who was starting teaching at his institution in the fall semester, and he shared the survey that he gave to his students, and I really liked it. I think he's teaching like a econometrics type class, and so I really liked the survey. There's more about the students and also about what they're concerned with about the class in there. So I've actually made the survey a version of it that is more adjusted for kind of teaching R and data science, available for others to copy. So if you are teaching and would like to take a copy of it, this is the survey that I used in my class this semester. And I'll share the link for the slides after so you can get to all of these pieces. One of the things that I really enjoy reading, and it was really eye-opening for me, were answers to these questions. What do you hope to learn from this course? What, if anything, concerns you about this course? And is there anything you would like me to clarify about this course? You would think that when you come in front of a classroom and say, are there any questions, you should be able to get the same information. But the reality is it doesn't happen like that. 2 other questions I asked, so I gave the survey after the first day of class, were Were you able to see the slides, and were you able to hear everything? And this is what the data looked like. You would think anyone who's saying no would have stopped me and said I couldn't see it. But this comes from personal experience of at some point in my life, I was a director of the undergraduate program, and I used to read a lot of student evaluations. You would be amazed at the number of evaluations at the end of the semester that say the font on the slides were too small. Any instructor would have fixed that problem. It doesn't matter whether you're a good, caring instructor or a bad one. People would fix this problem if they knew this was an issue, but students often don't speak up. So I think creating these opportunities for them to give you this information, and you can collectively get this information pretty quickly from them and then adjust your teaching accordingly, I think is incredibly helpful. Number 2, help them get help. We often say that, yes, you're going to run into difficulty as you're learning, and you should not hesitate to ask for help. But there's asking for help, and there's just banging your head against the wall. One of the things I really like in R is that help is built in, right? So that is great. But if you've never looked at the R help documentation, it is not necessarily intuitive to begin with. So this is from Kieran Healy's data visualization with R book, where there's actually an annotated version of the R help pages. I really, really like this. I use a slightly modified version of it, but I wanted to kind of give credit to the inspiration for it here. I think it's really nice to let students know what is happening in the curly braces. Oh, that's the package name. We're not born with this sort of information, and actually by the time you're teaching R, you probably have forgotten that that's second nature to you. Other things are actually teaching students that, maybe just reading the first few lines and then scrolling down to the bottom and running the examples might be good enough for you. You may not necessarily get every single word that is in the middle of that help document, and that might just be okay. I think giving them that confidence is really good. Another thing is, we often talk about, is I've certainly said this, we should encourage students to Google things. This is literally me Googling something last night. I did forget what were the possible joins that you can do. This is how I Google things. And if I Google things like this in front of my students, I think it's incredibly instructive. So I scroll through really quickly. I'm not saying anything. Then I scroll back. Then I scroll down. And then my eye catches some of the inner join stuff, and I'm like, oh, okay, this is what I needed to do. So I could do this in front of my students really quickly, but I don't think they're necessarily going to get something out of it. It is good for them to see me Googling stuff, but I think there's a tactful way of doing that where they can actually learn how to Google for themselves as well. So maybe I will do something like this. I teach with the tidyverse, so I would actually teach them to use particular keywords for doing their search. So join data frames with the tidyverse. And actually the first result that comes up is package documentation. That is going to be a lot more accessible, especially this particular one that has all the examples and the results as well in there. Is going to be a lot more accessible than a Stack Overflow post where there's many syntaxes being discussed. So yes, you absolutely should Google things in front of your students, but I think you should do it in a way, not the same way that you do it at home for yourself, but kind of narrate your steps along the way. Another package I actually really like is this package called SearchR, and it does the searching for you. So I'll give you 2 examples from the package. I think the first one's a bit gimmicky, but the second one is super helpful. You actually can use some of the search functions in this package. So there's search Stack Overflow, search Google, so on and so forth, and it'll pop up the results for you. Well, if somebody knows what to search for, maybe they would go ahead and search for it on that website anyway. But oftentimes what we get from students is that when they see an error, they're not exactly sure what about that they should search. They will put the data frame names and whatnot into their search, and then sometimes no results come up. So if you actually make an error, okay, so if you actually, so this particular declare code has an error in it, and it spits out there, and if I just say search Google, it will actually grab that error text and search it for them. You can set an option where it will pop open a search window automatically if you want. I find that to be a little bit distracting. Sometimes I think we want to give the students a moment to say, oh, I think I made a spelling mistake. But I think just telling them that they can just do this whenever there's an error seems to lower the burden for them and make it more likely for them to actually Google their mistakes. And then there's regress, which is about writing reproducible examples. So the idea here is that we want the students to fulfill the technical criteria so the instructor can do the human bits of things. If you haven't played around with the regex package, maybe you didn't need to, and oh my god, maybe you just never run into issues. But if you do, it is a great way of creating a minimum working example, a reproducible example for your question. The idea being that sometimes you actually solve it along the way, but even if you don't, you ask good questions, and I think that's the important thing. So this is usually the type of question I get from my students. This is a screenshot from Piazza, which is the discussion forum that we use for many of the courses that I've taught. I think many universities use this forum. It's great because you can do like code formatting and math stuff and whatever, but this is what text looks like. I'm trying to calculate summary statistics for MPG for cars with different numbers of cylinders, but I'm getting an error saying summary must be length 1, not 6. Can anyone help? Unless you literally ran into this 5 minutes ago, you can't. It's really hard to answer this question. And it doesn't matter really how much experience you have with R. The first thing we want is what code did you run, and also what is the exact error you ran into, not your interpretation of it. So what we can do is actually, so with the reprex package, what you can do is you can copy your code and then simply run the command reprex. And it turns out if you're going to be posting on something like Piazza, using venue R works well, and it will create a reproducible kind of example for you that you can simply paste into Piazza and then do a little bit of code formatting. And that isn't a lot better question for me to get. I have the exact code and I have the exact error in there. And more importantly, that's a much better question for other students to get as well. So then they're able to help each other and learn from each other too. Number 3 is live code early and often. I think live coding is a great way of teaching because you can narrate your steps, and this is similar to, for example, if you were taking some sort of a proof-based math course. You don't just want all the proofs in front of you. You want somebody to work through them for you at the pace that a human would be thinking through them. So live coding gives us the same experience, but if your live coding looks like this, maybe this is how you keep your RStudio window because you're really cool and you like the dark mode. That's great. But I don't think students are going to get a whole lot out of this. So there are a few things going on here. The colors are interesting, they're hard to read, and also, as you can see, the paint, if you're familiar with the RStudio paint, the order is different. So maybe this is your personal preference, but if that's not what your students' RStudio looks like in front of them, then they're going to be confused by it. This looks a lot better. Not cool, okay, but it looks better in the sense that you can actually read my code. Things are written in large font, and the layout looks exactly how the student's layout looks as well. So some live coding tips that I have is use the default appearance and font styles, zoom in and use larger fonts. Try to avoid keyboard shortcuts unless you're carefully narrating them. I think keyboard shortcuts are really good, right? They can actually make you a lot more efficient as a programmer. But one thing about live coding is that you don't have a camera in front of that is actually showing your fingertips, right? They're only seeing what you do. So if you're jumping around the screen at a pace that's hard for them, they're not going to really learn from that. Now, if you're not teaching shortcuts, that's great. And you can actually narrate your way through it, and that would work as well. Test your physical space and back with the classroom. One of the things I like doing is, before I teach, I will actually put my slides up and go to the very back of the classroom where I know at least one person will be sitting, and actually try to see, is my code legible from that distance? I would also strongly recommend recording any sort of live coding session if it's longer than, say, 5 minutes or so. This is especially true if you have students where perhaps their native language is not the language you're teaching in as well. It allows them a chance to go back and actually re-listen to you. Again, live coding is good because it's real time, But the reason why we also like slides is that they create a permanent record of what we said. So if you're going to be doing the live coding, it's essential to try to get a permanent record of that. With any computer that you have, it should be quite feasible to take a screencast that just takes your audio. I don't think they need to see your face. Just takes your audio, and you can upload that video to YouTube as an unlisted video if you don't want the whole world to see it, and simply share that with your students. Maybe 10 of them are going to use it, but trust me, those 10 are going to be incredibly thankful that you have done so. And another thing that you might consider is actually doing broadcasting. I've been playing around with this a little bit in two ways. The one is a low-key way of setting up something like a Zoom or a Skype session or whatever it is where you could be sharing your screen and actually having your students tune into it as well. Not as audio, but just simply the video. So what you're doing as live coding appears on their computers as opposed to simply on the screen. That can get a little bit dicey if the Wi-Fi isn't going to be good enough in the room that you're teaching for 60 or so students to be kind of logging onto a video stream at the same time, but it might work, and it's something you might consider. There's a new package that LatinR has been working on that I am very excited about, and I've been testing. It is a work in progress, but I would encourage you to take a look at it. And so what we're doing here is that the R code that the instructor is writing in the script is actually being broadcast to the viewer pane of the students, and it's actually copy-pastable code. So instead of being a static image where students would still have to type, they can actually copy and paste it. I think there's some intricacies around getting the right kind of access point. Do people have to be on the same Wi-Fi or not? Is something I think perhaps Colin was working on. But in the few instances that I've tested it in class, it works out really nicely. And I'm hoping that there'll be more of these efforts for like getting live coding right. And doing so in the IDE where the students are working so they can actually interact with what you're writing. Inevitably, if the live coding is good, but then students are watching you. So the idea here is that how can we make them actively participate in that experience as opposed to simply watch you. Number 4 is leverage visuals. I'll give a few examples from some of the visuals that have really helped me along the way or that have been very memorable for me. One of them is from Hadley. This is I guess it's 2015. It's been a while, but I do remember this very well. Where you can kind of see, how you do the indexing of the lists. If you've seen these images from Jenny Bryan's her tutorials where there's these Legos, and I've linked to actually the resources where you can find all the Lego images. This was incredibly useful for me to figure out what list columns are, to be honest, because I couldn't quite visualize them in my head. And there's also all these nice visualizations from Alison Horst, who's been making these sketches of various packages and whatnot. And sometimes a picture is worth 1,000 words. I could explain to you what WePrex is, or if you know Spanish, maybe that's a big deal. So there's the Spanish versions of these illustrations as well in her repository, and they are Creative Commons licensed, so you can use them. And I think they're a cute way of bringing in another way of saying something that you would be saying to the students anyway. I will end this bit with a caveat, though, is that I am a big kind of proponent of speaking with visuals, teaching with visuals. But I did recently, after a talk I gave, get this semi-criticism or comment of saying you can't just rely on visuals for teaching because that's actually not wholly inclusive either. For some students, either they're not visual learners or perhaps they actually have vision difficulties that they can't see, then that's not going to be good for them. I wish I could follow this slide up with, and here is an answer to that. I don't personally have an answer, but I did link to this slide that actually links to a project that thinks about what are different ways that we can kind of think about data without visuals. If you know of other people who work in this area, whose work we should familiarize ourselves with, I would be very interested in finding out. I think it's a great comment, so I'll leave it at that, where yes, visuals are really, really effective for some students, but it's not going to necessarily establish whole inclusiveness either. Number 5 is define and pronounce terms. So here's the one where I remember this very well, even though it's been over a decade. This was the day where I was like, yeah, I don't think I'll I'll ever get R. I don't know what any of these words mean. I think there was a reason why I had to look up what a double is. I don't have a computer science background. This is simply from the help page for if you just do question mark double. And I honestly, in my first couple months of learning R, had no idea what this meant. This is not to say the help page is wrong or bad. It is intended for a different audience, but I think it's important that if your students are going to encounter these things, and you don't want them feeling lost, you also teach them the terminology that might be the minimum requirement for learning certain things. We're talking about teaching R for data science, not necessarily teaching a computer science course, but there are certain aspects of the documentation and the help files that students might commonly encounter where having some working knowledge of certain computer science terms might be helpful. And so it is, I think, on the instructor to try to figure out what a set of minimum list of vocabulary is and teach that to the students so they actually feel equipped to handle everything else that might come their way. The other one is pronunciation. This is a big difficulty for me. English is not my first language. And the way I mispronounce things is different than how Americans whose English is their first language mispronounce them. And if you mispronounce something, sometimes people look at you funny. And that look might be enough for you to never ask another question again. So I linked here to a talk. If you haven't seen this video, a talk from our Studio Conf last year, Feline's Explicit Direct Instruction and Programming Education talk. It's really good, and there's a bit about pronunciation in there where you should be reading code out loud to your students, so when they want to ask you a question, they know how to ask you a question. Otherwise, maybe they would be willing to write their questions up, but they're going to be really not willing to actually raise their hand in class and ask you the questions. Number 6 is highlight diversity as much as you can. And I guess I should say, along with highlight diversity, try to think about places where it is unnecessary to be mentioning things that don't highlight diversity to begin with. And I'll start with an example from kind of a look back that I have done recently for a project I've been involved with. I work on the OpenIntro project. We write open source introductory textbooks. And we started this project when we were graduate students, and it's been growing. And recently we had a new edition of one of the books come out. And one of the things we did systematically going back was to look at situations where the example used a binary gender variable. And really, we could have used something else. Like, it wasn't necessary that we talked about gender in that example. It just so happened I had a data set laying around. Maybe I was teaching comparing two means or something like that, so I ended up using that. Looking back at this, we actually replaced about 30 of the exercises in the book, along with one of the 8 computing labs, the data sets, to be something else. This doesn't mean you shouldn't talk about gender in your class. It just means be cognizant of how you're talking about it and think about, is this the place where I want to be talking about gender as a binary variable? Or could I simply get away with giving an example with left-handed versus right-handedness and leave the gender discussion to a point where we're actually talking about gender? One really good resource for this is this article on Significance Magazine. And I think Significance Magazine requires subscription, but this particular article is openly available, called LGBT plus Resources for Statisticians and Data Scientists. And there is tips for how do you start the first day of class, what are things you should be paying attention to. There's also a section on if you teach in industry as opposed to an academic setting. But there's a really nice section on certain data sets that you can use. So these are kind of handpicked data sets where either you could be talking about LGBT plus issues, or there is a gender variable that is not binary labeled. So it could be talking about something else as an example. These are all openly available data sets that you can incorporate into your classroom. And one of these bullet points actually points to a whole repository with more data sets as well. I've been able to grab a couple of these data sets and pretty easily get them into R, get them in Shape, for example. So I would encourage you to take a look at them. The other one is language diversity. I think many of you know about these projects, both the Spanish translation of R for data science and the Datos package. There's also the wonderful RStudio cheat sheets, and people have have been submitting translations of those. There's many languages. I highlighted the Turkish one there because I am a Turkish speaker. My native language is Turkish, although I don't think I could write the cheat sheets. But one of the things that I will mention about this is that, if you are teaching, say, in Latin America, maybe this is obvious. But I don't think the highlighting of these resources for other languages should be limited to the geographic area. Even if you're teaching in the US, chances are you have students in your class whose native language is not that. Sure, their assessment might be in English, but that doesn't mean they wouldn't benefit from these other languages. So I would encourage you to not assume and not necessarily just stick to what the official language of instruction is, but if you happen to know of resources, give that to your students. Some of them might use it, some of them might never look at them. But the few who use it will actually be thankful. Number 7 is providing instant feedback. When you're learning something new, it is quite frustrating to have to actually wait for feedback, especially if you're feeling like it's hard for you to articulate your questions. I think one of the good examples for this is a package called LatinR. So you can write these tutorials where you can check the student's code and then actually give instant feedback to them. The code checking aspect of it is maturing at this point, but if you are interested in working on kind of instant feedback type of stuff, I would encourage you to work with try out LatinR and the Greatest packages and give feedback back to the developers, because I think we're trying to get it to a point where it is a bit more usable. But another project that I've been working on is to leverage software engineering tools to see if we can provide instant feedback to students. So when I teach my art and data science courses, we have the students do their work in GitHub, so everything they submit is a GitHub repository, and you can actually hook up continuous integration tools to a GitHub repository as well. So one of the things that's really easy for a machine rather than a human, a machine to give feedback on is code style. I want my students to follow a particular code style. And the nice thing about code style is it has nothing to do with interpretations. There's no aspect of, is this the right model to fit? You literally can write the code that goes along with highlighting where the code follows a particular style or not. So leveraging the styler package that uses the Tidyverse style guide, we can actually run a styling function on student repositories, which will create an issue for them. And actually the issue will link to the Tidyverse style guide, where they can go back and read more about it if they want. But this is what the difference looks to them like. And so you can see there, it's really mundane things, like you're missing a space here, you're missing that there, where it would be annoying for a human to have to write. But just seeing it visually like this, your students are quite likely to actually go in and make those fixes. So we submit these as a draft pull request to the students, so they can't just merge it in. They have to actually think about it and make the fixes themselves, but it is not something they get graded on at this stage. We have it running on a daily basis as the repository is open, so during the duration of the homework assignment. So at some point they might wake up one morning and see, oh, I have pushed some changes to my repository last night. Here is the automated feedback that I've done. With automated feedback, though, it's really, really tempting to just point out negatives, because you can write code that says if it doesn't match this, then make this alert to the students. I don't have this well implemented yet, but it is something that I try to keep in the back of my mind is take a note from the praise package. So that's a package where it actually generates random praise sentences for the student, for the user. And so we'd like to incorporate some of this into the automated feedback. So in addition to pointing out the negatives that need to be fixed, we also try to point out positives and or give some encouraging statements to the student. So it doesn't feel like every time there's a notification that there's an issue open in your repo, they're like, oh God, what did I do now? We want them to think about, I wonder if I did something right as well. Number 8 is invite peer feedback. So I think peer review is an incredibly useful tool for making expertise contagious within your class. class. So if one student knows, they're going to learn from the other student as well. And it helps students see their work through another's eyes, without the instructor having to point out the flaws. And I think there are two benefits to it. The selfish benefit, you as the instructor don't have to be the one doing the review, at least in the first stage. That will save you some time. But more importantly, this feeling of, I must be the only one in the class who's not getting it, happens a lot to students. And if they actually see other students' work that feels on par with the positives and the negatives with their work, they're going to actually feel like, okay, I think I'm doing okay, or at least I'm not on the very lower end of the tail for this class. But if they see that peers' work is a lot better, they're going to learn from that as well. Obviously, they will learn from your teaching materials too, but being able to see it from another level and also to get feedback from another student, I think is really, really useful. One of the things that is a bit hairy about peer review is implementing it in your class in terms of how do you distribute things to students and collect them back, how do you do that in an efficient way. So as I mentioned, I teach with GitHub as my learning management system where all of the submissions are happening as GitHub repositories. So over the past summer, I've been working with one of our RStudio interns, Chris Anders, on developing the functionality for the GH class package for doing peer review. So the idea here is that we randomly assign repositories to other students, and with the use of, I think if I remember, 6 main functions that do this peer functionality, we're able to give access to other students so they would actually do the peer review and then move their feedback back to the students who submitted the work. And then also the students who submitted the work can actually give a 1 or 2 sentence comment back to their reviewer saying this was helpful or this was not helpful. So this is something we've tested kind of at the package level, but I'll be implementing it in my class this fall. I'm sure I'll blog about it. So if you're interested in it, follow up with that. And if you do teach with GitHub, I think this is a good way. If you don't teach with GitHub, but you are interested in peer review, there are other mechanisms that mostly faculty from departments like writing or English actually tend to use for doing this sort of distribution. And there's good research on kind of the effectiveness of peer review in terms of learning. So if it's the technology that's holding you back, let's chat and see if we can, help get you there. I think it's a really good way for students to learn and to lower your burden for grading. Number 9 is signal posts. So what I mean by this is that you get a chance to highlight what you're going to show your students beyond just the material that you have curated as a list of topics for your class. One of the first things I like doing in my class on day 1 of class is show them a few blog posts, something fun they could do with R, and try to scope it out in a way where it could potentially be something they genuinely could get to by the end of the semester, if they actually tried. Not something hugely advanced, but something they could get to. So at that point, I actually get to choose whose blog posts I get to signal. These were the 3 I used literally last week, so those are the 3 I picked. So Bruna is a PhD student in Ireland, actually. Our music tastes are alike, so I like her music posts. She writes about Belle and Sebastian sometimes. So I show them that. But so this is highlighting a package where you can download some lyrics, and there's some nice visualizations that goes along with it. Brooke Watson had this blog post about the USFA. Everyone loves Beyonce, so it's about the increase of the name Beyonce. So that's actually a interactive or a dynamic plot that kind of shows the changes, something our students could get to with a package like GG Animate easily. And I think Julia Sogi requires no introduction, but I like her analysis on like Jane Austen stuff. But this particular blog post I like because it's not even about the text. So even if you don't know the books, you might actually still find it interesting because it's about the punctuation and stuff like that. So these happen to be 3 women who do data science. There are wonderful other people out there as well, but these happen to be the 3 that I chose to signal post this time. I think it's useful to try to think about who you're signal posting and try as much as possible to find people who look like your students and actually put their faces on your slides as well. So I have to do a plug for Our Ladies. This wouldn't be a good talk without that. Our Ladies is wonderful, but one of the things it's wonderful for is this directory that's maintained, and there's actually a list of all of the Our Ladies members, and many of them have blogs, many of them write stuff, and those are linked. Many of them are actually speakers as well. You might consider maybe some of them would dial into your class for 20 minutes. It doesn't even necessarily require a flight or funding to do that. And you might have them, if you're teaching something that's relevant to their work, they might be willing to talk to your students for a bit. So I encourage you to browse it if you're looking for inspiration for what to signal post. That's a good place to start. And number 10, lastly, is make room for creativity. This is how I like making room for creativity. This is literally my final project assignment. It just says take a data set and do something with it, okay? There is more to it because students want to make sure that they're going to be assessed on this, so I think it's important to give them information on how they're going to be assessed. But in short, this is what the assignment looks like. So if you have the bandwidth in your class, this is a great way to end a course on art and data science. But you may not always have this sort of bandwidth. If you don't have the bandwidth for being able to carry out, if you have 500 students or something like that, open-ended projects for each of them, even a team project is not necessarily feasible. There are other little things that you can do that allow for creativity. So I'll give 2 examples from those. This was a faculty member, Drew Steen, who I guess asked his students to make the ugliest ggplot2s ever. And if you actually look at that Twitter thread, oh my god, they are ugly. But, imagine the last time you tried to flip those axis labels 45 degrees. It requires some learning. So this person managed to get them in that font, in those colors. They've learned a lot doing it, and it's a fun way of doing it, and it's one way that they can actually bring out their creativity. Another nice assignment is this one about drawing a Christmas tree. So this person has been collecting all the different Christmas trees. And if Christmas tree is not your thing, pick something else. I don't know, draw a star, whatever. Draw something in R. And so if you go to this link, you'll see all the submissions for various ways of drawing the Christmas tree. Again, the idea here is that there is not one right answer. And given that there is such a thing as abstract art, just about anything would pass. So students are actually set up to succeed in some way because it's something that's familiar to them. And it's one of those things where, if I had to hypothesize, I would guess that it's one where they might be willing to spend a bit more time just trying to get right than maybe it's a slightly more standard data science assignment that you might give them. So I will kind of end things here, but I'd like you to think about if you have other tips or resources that you would like to share that you think would fit well in this paradigm. I'd like to kind of start collecting these tips and start, curating them perhaps in a GitHub repository. So my contact information is here. If you think of stuff, just reach out to me. The slides are at that link. And I have to mention that the illustrations, the wonderful illustrations that were in my slides are by Desiree DeLeon, who actually made them for the RCDO Education website recently, but they're Creative Commons licensed and they're available on her, I think, repository as well. So I wanted to give a plug to that as I end. Thank you very much.
Good morning, I'm Fernando from Brazil. What do you think about gamification as a strategy for teaching a more straight way? Is this a useful tool?
Could you say it one more time? I missed the
gamification. What do you think?
Gamification?
Yes.
So I think it is a useful tool. I think it must be a useful tool because platforms that do the gamification seem to fare well among a certain subset, at least, of the population. So what I do know is that that I don't think it's for every student. And I think I would hesitate to make something that's gamified to that level as part of formal assessment. But I do acknowledge that it is a motivating factor for some students, so it would be something I would be kind of thinking about giving as additional exercises on the side. One gamification assignment that I sometimes do in a modeling course is where we have kind of a leaderboard for like the best prediction type of thing. But even in that case, what I like doing is actually students don't just show what their RMSE number is, but actually have to link to their model as well. So it needs to come with some explanation as to why they're winning, but people like that type of stuff. But I think I would hesitate to make it part of formal assessment because I know certain students are going to find it quite stressful, actually.
Thank you for your talk, for all the wisdom that you just gave us about teaching. It's wonderful. I got a bunch of tips, but this is not a comment, it's a question. Do you have any additional tip about when you talk about defining the terms, how do you present that to students? Because I've been in that situation and it turns out to be like a members list, very difficult to learn anyhow. So do you have any insight?
Right. So I have thought about two ways of doing it and actually landed on the latter. The original way was, over the years or semesters of teaching, why not collect a list of words as a glossary and make that available to the students? I think that can work for some, but for many students, what they see that as is another list of things to learn. And I don't think that's the intent of that. So one thing I try to do as I prepare for a class is try to run through the material the students would and go back and look back at the help files and stuff and just do a 10 or 15 minute sanity check of, are there these terms that will pop up for this particular teaching session that I might have as kind of call outs on my slides. So do it just in time as opposed to providing it as a complete glossary. I think glossaries are helpful. People like being able to search for them. I try not to make them as part of kind of official teaching materials for a graded course because what I've sensed is that students feel like, should I memorize these as well?
Hi, my name is Gabriel. I did your class yesterday. And my question is, which is the ideal number of students that you think that is ideal for a art class?
Really good question, and I wish I had a good answer for you. I think I think the ideal number of students depends first and foremost on the space you're teaching in. I think it's really, really useful for students to be able to have their computers in front of them and do active learning exercises where they're not balancing a laptop on their laps. They actually feel like this is a space I can learn and collaborate. So I think space really governs that. And then I think I am of two minds. Small class sizes are nice for having one-on-one connections with students, which is something I cherish over everything else. But at the same time, if there's a thirst for learning this material, I don't want to turn anybody away. So I think that it is on, at least I'll speak in the case of an academic setting, I think it's on the institution to try to solve this problem of there's this many people wanting to take this art data science class, let's try to make it happen somehow. Obviously things don't get resolved just because you ask for them, but I think constantly asking for more resources if you see that the demand is there is helpful. But otherwise I would say whatever space you can find where students could work actively, and if there's going to be any more than 20 of them in the class, I think it's really useful to have at least one other person to help out during the active sessions.
¿Alguna pregunta más?
I am an agronomist, and I teach to agronomists who hates the statistics and obviously any programming language. What do you think that in a class you need to concentrating on statistics or in programming with R, because they need the two things to do their work.
Right. So I think that if what they need from this class is both of those things, emphasizing one over the other is not the right way to go. If they need to be learning to fit models in R, but also learn the theory behind these models, then you have to split your time accordingly for that. I think the first and foremost, the important thing to show people who might be taken aback by this is try to motivate them as to why it's useful to learn R. I don't know if you're talking about a graduate audience or not, but even if not, I think one of the things that I've taught economics PhD students as well, who have been doing their work in state for years and years, and they're happy with it, but they've heard about R and they want to learn about it. R Markdown is like the hook for getting people interested in saying, oh, okay, so I can learn this, and this is what my workflow becomes. So I think thinking about things like this, certain packages that will really make them easier for you, whether that's on the modeling end or on the workflow end, like our Markdown, and highlighting them as early as possible might help with the motivation factor.
Hi. So you mentioned students may have different ways of learning, like some people are more visual, some others are not visual at all. So I was wondering, people have different paces to learn as well. How do you handle these different paces?
So people having different paces, that's a really good question, and I think that's a hard question, especially when you're teaching with deadlines and grades. I think that there are a few things that one can do in terms of giving some breathing room. I am not good at this yet, but it's something I thrive to do. Whenever I prepare, let's say it's a 15-minute teaching session, try to carve out 10 minutes of it. Like if you can, think about what could I take out of this thing and still get my point across so we can go a little bit slower, I think helps everybody. Other things, this next thing I'm going to say is not really specific to R, but I think having course policies that allow people to get away with a couple bad days is really, really helpful. Drop the lowest homework, drop the lowest lab, whatever it is. Just give them that flexibility and the responsibility that comes with it. So they don't feel like every single thing on the syllabus has to be turned in. So if they feel like they need to take some time, perhaps they can do that. Beyond that, if the issue is that they're certainly not catching up with the class at all, then I think that requires a more personalized approach. But I think these policy level things that you can do at the higher end will catch quite a few of the students who might be struggling at times in the class.
So thank you very much, Nina. That was awesome. Y muchas gracias a todos. Un par de informaciones prácticas. Las sesiones que vienen ahora van a ser al frente del mismo lugar donde fueron los tutoriales ayer, auditorio 2 y 3. El café también va a ser allá, así que